Hello everyone. I hope you're doing good at your places. So up till now we have discussed the basics of gears, how they work, how they transmit the turning effects. Now we are going to how we can change the gears and many other concepts related to it. So up till now we can say that gears are basically similar to lever and they are used up for the multiplication of the effect of turning force using moments. They are consist of wheels and which are tooth edges, wheels with tooth edges. That means their tooth are edged with other wheels. Okay, so if this particular wheel is rotating, is doing some kind of rotational motion, then it is compulsory for the other wheel also to get hinged up, which has got edged up with it. It will also going to do a rotational motion. If it is going downward in this particular position, it will have to go downward in this position. And the result is this will going like this and this will going like this. So if one is having a clockwise rotation, other will have a anti-clockwise rotation. I wish I can show you this. Suppose that's the hinged part, okay, and this is the driver one and this is the driven one. All right, so what is going on in this? If it is rotating in this direction, so you can check it out, the direction, suppose, yes, this is the right way. If it is rotating, if it is hinged like this and it is doing a rotation in this or in this axis, so you can see that both are doing a rotational motion which is opposite to each other. The remote is actually doing a rotational motion in clockwise and this particular machine is doing a rotation in anti-clockwise direction. So we can pick up many other examples in our surroundings by which we can see if the rotational motion is got hinged up wheels is showing up, then both of them will going to show at opposite direction. Now the we can say that they are consist of wheels with tooth edges and rotate on an axle or shaft which acts as a pivot. Okay, the teeth of one gear fit into the other tooth and this let one gear turn the other, meaning one axle or shaft can be used to turn another shaft. So we have did all these things up till now. Now my question is, when the gear meet, the teeth will then move in the same direction, either downward or upward. Is that right? Or they will going to do opposite motion? I just explained it right now. See, if this is the motion, if this particular motion is doing downward, that means where the gear meets, the movement will be the same direction. It will either downward or upward. See, if they are doing an upward motion like this, if they are doing a downward motion like this. So for an upward motion or a downward motion, we can say that the rotation of the shaft will be opposite to each other. If one is doing a clockwise one, other one will going to do a anti-clockwise. This is the best example you can see in this, that this is particular is the driver wheel and this is the driven, or you can say driven wheel. This is also a driven wheel and it is also called as follower, which will going to give me an output. So we can say that this driver wheel is giving me an input. This is the driven one and this is giving me the output. The shaft is giving me the output. All right. So there are a few more facts that you need to know in this, that although the force will be same on the both gears, the moment will not be same. Moment of gear will be equal to force applied. We can call it torque also. Force applied on the shaft, on the gear, into radius of the shaft. Radius of the wheel, you can say, radius of the gear, you can say, whatever you feel like. All are same. There is nothing much difference. Gear wheel radius. Okay. So whatever is the gear wheel which is using up right now, we can put any of them. So we can say that the gear wheel is working upon it accordingly. So here it is. We can say that the force will be same. The force, what will be the force? The force will be the same as given by this particular engine region. Okay, whatever force has been given up by the engine, the fuel got a spark, there will be a rise in temperature, there will be a movement in the piston. This is the piston, this black moving part. You can see this black moving part, guys. This black moving part, which is going to do an upward and downward motion. You can see that red spark over at the above side. So that above red spark is going to give a you can say this red spark is actually giving it a expansion. Okay, and this expansion will going to create a pressure on the piston, and this piston is applying a force. So by the force of this piston only the whole motion is going on. So we can say that the force will be same, but the moment will going to vary. All right, so moment will be dependent on two things. First is force, which is same. Second is the moment of second is size of the particular wheel, okay, or gear. If the gear size or gear wheel size is higher, it will give us a larger moment. If the gear wheel size is smaller, it will give me a lesser moment. So what will be the moment at this place? Moment of driver is always greater than the moment of the driven wheel, and of course its driven wheel moment will be less than the moment of the follower. So here it is, this moment can vary according to the size of the driven wheel, because force is same, we know that in any kind of motion. So if we say, if a larger gear is driven by a smaller gear, then what will happen? Larger gear is driven by a smaller gear. What will be the effect on it? Then we can say the larger gear will rotate slower than the smaller gear, right? Larger gear will rotate smaller. Why so? Because the larger gear will going to do one rotation, and in that one rotation the smaller gear will going to do rotations. You can see that in this. Can I rub the whole screen? Whatever text I written in this? Yes. Please erase all these things. Okay, I have removed the unnecessary part of it. So now we can do that what we want. So here it is, guys. The if my driver wheel is larger, okay, so when this whole driver wheel will going to do a rotation, till that moment our smaller will be going to do 3 rotations. Why? Because its size is too small as comparable to the driver wheel. So in such case, what will happen? There are two cases, guys. If larger gear is driven by smaller gear and smaller gear is driven by larger gear. If a larger gear is driven by a smaller gear, the larger gear will rotate slower. My larger gear will going to rotate slower. You can take this example as, you can take this as an example. It's this much of motion. Suppose this is the driver one. If it is the driver one, the smaller part is the driver one, the larger gear will going to drive slowly, because when it is going to do a 2 rotation, it will go 3 rotation, it will going to do a single. So for single rotation, it needs to do rotate 3 times. Okay, so the first gear will going to the driver gear. You can say, driven gear will going to go slower, and then the smaller gear, and will have what kind of moment will it have? It will going to have a larger moment. Is it clear, guys? If a larger gear is driven by a smaller gear, the larger gear will rotate slower than the smaller gear, but will have a greater moment. That means its moment will be higher. In spite of rotating slowly, it will achieve a larger moment. For example, you can say a low gear cycle, low gear bike, or a car. Okay, and if this is the example where my driver is this larger one and driven part is smaller one. In such cases, my driver wheel will go slower. So a larger wheel will be faster, it will go faster. Its rotation velocity will be high, and we can say it will possess a very small moment. Why so? Because we know that force will be same and moment is equals to force into the radius of gear. So obviously radius of gear is too small. So it will going to possess a lesser moment, a smaller moment. So we can say that this is because the turning force on the larger gear wheel acts further the turning force of the smaller gear wheel acting on its own pivot. Okay, so this is all about how we can proceed with the gears. Now we will going to understand this concept, guys. This concept is actually different. In this, the gear system is worked upon with the help of a chain. So you cannot say that the tooth are hinged up. No, in a case of bicycle, the tooth are not hinged up, they are hinged up with the help of chain. So chain is rotating them. You can pick up one more other example. I'll show you at this place. In this, what you can do, you can have a shaft like this, and in the shaft you can have a rotatory wheel, cross it, and with this rotatory wheel you can have a rope, small chain or rope attached, something like this. There will be a mass, there will be a force that you need to apply. So you can see that there will be a turning effect. Okay, obviously there will be a turning effect. So that turning effect will also be used up as a gear. We use in earlier days, in very older days, you can say, we used to just take out the water from the well with this help, with the by hands. In this way we just keep a bucket or any kind of box, or usually a bucket. We used to hinge that bucket, or we used to tie that bucket with a rope, and we just keep that in that particular well and drop that down and then take out the water with the help of this type of pulley system, you can say. Okay, so that is also a gear system. You can call it a gear system, obviously. Okay, so we use such type of system many a times in our normal daily life. So here is the question, guys. Let's practice that. A gear wheel of radius 20 mm. So here I got the radius as 20 mm. Thank you. Can I convert it to standard unit, guys? What is the standard unit for us? That is meter. So 1 meter equals to 1000 millimeter. So I can say 20 into 1 upon 1000 meters, and it will be almost equivalent to 0.020 meters. So that will be my new radius. Okay, a gear wheel of radius 0.02 meter is used to turn the gear wheel of radius 10 meter. Are you getting the point? Okay, I'm marking the second radius. This is R1. There is R2. That is 10 will also be equivalent to 0.01 meter. And they are driven by a force, that is F, which is equivalent to 80 Newton. So what will be the moment of force? Calculate the moment of force for both the cases. The moment of force M1 for first case, that is 20 mm. Okay, so let's just clear the case first. The case is a gear wheel of 20 mm is used to turn the another gear of wheel. Okay, suppose this gear wheel is there. So that will be my first one, and here will be my second one. So here it is. It should be 12, I should say. Suppose this is the one. So this is having a radius of 0.02 meter. Okay, I'm marking here 0.02 meter, and this is having a radius of 0.01 meter. Both are hinged together. Okay, this is the driver wheel. That's the driver one, and this is the driven one. You can say follower also. It's all your will over here. Okay, so we need to calculate the moment of force by both, on both. Okay, on 10 as well as on 1 So I'm marking for M1, that is 20 first, as I have marked 20 first for the case. Okay, so here it is going on. M1 will be equivalent to F into R1. So F is around 80 into R1 is around, yes, it should be 0.02. So 8 into 2, that will be 16.16 Newton meter. Okay, that is 0.16 Newton meter. That is the first moment. And the for first part, it will be M2. That will be equivalent to F into R2. So what is my F? Force is same. We know that in a case of such a gear system, the force will be same and moment will be dependent on the size of the object. So 80 into R2 is around 0.01 and it will be equivalent to 80 to 1.8. Should be 0.08, I think. No, it should not be 0.08. It's 80. I'm so sorry. Made some mistake in this. 80 into 2. That will be equals to 160. Na? 80 into 2 will be 160. 1.6. It should be 1.6, I think. Okay. So it will be 1.6 Newton meter. And at this point, it will be how much? 80 into 0.01, 0.8. 8. Just half of it. It will be 1.6. It is 0.8 Newton meter. I hope it is clear to you all, guys. They said they are having a gear wheel of radius 20 mm and is used to turn another gear wheel. Okay, they are just hinged like this. This is the smaller one. This is the larger one. Larger one is the driver wheel and smaller one is the driven wheel. So here are the moments and you can just calculate each and everything related to it. Okay. Okay. What determines the moment of gear wheel? We know that for a gear wheel, moment of force is equivalent to force into radius of gear wheel. And we know that in case of a gear, the force will always be same. So what will going to vary? If this force will going to be same, it will not going to vary. So what determines the moment? Something which is used up for determining the moment of wheel, we can say that. Can I have? So for finding out the moment of gear, what is the changes in the gear moment of gear wheel, we can just focus on the radius. That means we can say that radius of gear wheel is required. Radius of answer is yes. Radius a gear wheel. Oh no, cannot do that. Radius of a gear wheel. Radius of a gear wheel will going to determine, or we can say that what will be used over here? Size. Because if the radius is higher, size will be higher. If radius is smaller, then obviously size will be smaller. So we can say that what change the movement of a gear wheel is the size of the wheel. Or you can say radius. Both are similar, you can say, if they can be used up as both ways. The moment of the force on a gear wheel of radius 40 mm. So guys, what do we have right now? We have radius of a gear wheel. Radius of a gear wheel of is 40 mm. So it will be around 0.04 meter. I have changed it into standard unit, guys, and should always be less than. They have given me a moment of force and they have given me the condition should not exceed this much of value, 4.8 Newton meter. We know that the moment of force, which is equivalent to force into radius, so F will be equivalent to moment upon radius. So what is the moment? Moment is 4.8 Newton meter over 0.04 meter. So we cancelled out and I can put 100 over here. It will also going to be cancelled out and I can put a 10 over here. 0 has been cancelled, like 0 other 0, and it will be 12. So it will be equivalent to 12 Newton. Force, maximum force on the gear wheel, make it turn, is 12 Newton. It should not be less than that. Okay. So This is the way how you can proceed on any kind of question like that. And if they give you the value of size, or you can say if they are giving you the value for size, or I can say the value of a force, or they are giving you asking you for moment, you can do that. If they are giving you a moment and radius, you can find the force. If they are giving you the moment and force, you can find the radius or size of the gear wheel. They will not going to directly ask you that find the radius. They'll just ask what will be the size, which one will be the great, which one will be the larger, which one will be the smaller. It should always be in your mind. Okay, you should always be just in your understanding that if they are asking for size, they are definitely asking for the radius of the gearway. Okay, so this is all, guys, for today. And for understanding of other concepts of the physics related to our force and its balance and in action, we can say that center of mass, we will going to continue that in our next lecture. So thank you, guys. All the best for your further coming up examinations. Thank you.